into a fully operational state. So the main parts that are relevant is probably, we have here roughly 10,000 nodes, compute nodes, and then our storage system listed down here has 220 petabytes of usable storage, and then the targets here above 25 terabytes a second. If I go to this slide, this is a little bit more specific to the storage architecture, but the main takeaway I want to get to on this is if these red blocks represent the DAOS servers, they're actually part of the high performance fabric that the rest of the compute system is on. So rather than traditionally we would have our Lustre storage system on its own storage network, and then it would be connected in through some kind of gateway nodes. Here in this case, the Aurora DAOS storage is directly connected to the Dragonfly Slingshot fabric. All right, so I've arranged this talk in a little bit of a strange order. I'm going to tell you about the more recent things we've been doing, and then I'm going to move to older things and talk a little bit about that. It's more historical, so less relevant, but there's a few interesting things in there, and then end with maybe the most current thing. Also, before I kind of go forward, I do want to apologize. I have to leave early at the break because my boss told me yesterday he's going to not attend a meeting, and so he's forcing me to go and attend that meeting. So apologies to all the future speakers. But catch me at the break if you have any questions. I'll still be here. All right, so kind of what's the most current thing we've been doing on Aurora? So we've had the storage for a while, but now we've added the compute nodes and had at least some access. So now we've been able to start testing with our actual compute blades accessing the DAOS storage system. And we've added some external users on the system, and there's just generally more work being done with the compute system, and we're able to leverage DAOS using that. And so the Intel team has started looking at application scaling, and so they've been doing some work testing some benchmark science codes using DAOS and looking at the performance. Of course, they've been doing various performance analysis related to the third bullet there, IO 500 testing, and that'll be the last topic I talk about. In addition to that, there's been lots of testing on 2.4, so Intel team's been doing all sorts of hardening and verification for the 2.4 release. On the Argonne side, what have we been doing? Well, we recently requested from all of our storage servers, we said, Intel, give us some servers that we can use for ourselves while you're using the rest for testing. So we have 40 nodes allocated to us, and so we're going to partition those in so somewhere between 20 and 40, but maybe let's say 20 for now. So 20 servers will build a production-like storage system to let the users of our system to use that as they see fit, and then we'll kind of, my colleagues in the operations side will maintain that system and run it. While the remainder of the nodes that aren't in that production thing will be used by the operations team just for general testing. Whenever we want to roll out a new image or whatever, we can just use those other nodes to test those things. And so on top of just being able to do some production-like study on how DAOS is working for us, we also want to kind of improve the use of it how users interact with it. So we want to add some hooks into our scheduler so you can just tell it, this is the pool and container I'd like to make available, and then the job prologues will mount that before your job starts. So you could assume that if you were using a POSIX container, that it would be mounted at the location that you want it to be when your job is starting up. And then it's sort of a side thing because we have a rule at Argonne that when we have a new system that's in the pre-production state, it's not permitted to connect to any of the production resources. So all of our production file systems are not currently connected to Aurora, which leaves us sort of short on any kind of storage. So we're going to experiment maybe using home, and home is like your traditional home file system. And then we always have a file system we call soft, which is where all the software that we would build and provide to users. So these are like math libraries or other scientific codes that maybe have some more common usage. We'll install these on this volume and then make those available. And that's not what the plan would be for using Aurora in production, right? It's the main data high performance storage. But for this small storage system, this might be a benefit for the users while we're in this pre-production state. So we're going to do some experimentation on that. So hopefully I'll have something to report about that in the future. And then one of the things I've been personally spending a lot of time over the last year was working on the DAOS Foundation. And so I kind of put in my own slide here just as to reinforce what was stated earlier, that I'm personally excited about the foundation, very much looking forward to getting other people involved and just kind of expanding the ecosystem of DAOS to other places. And so, if you have any questions that you don't want to ask Intel or some other one, you feel free to ask me about the foundation. Happy to talk about it. All right, so now I'm going to move into the past a little bit. So this is much earlier in the year. We have this Sunspot system. It's a test system that's meant to look like Aurora, and so you can kind of see some of the facts about this. But we had a 20-node storage system set up for DAOS running on this thing. And probably the key for this slide is we were running DAOS 2.2, and we could never upgrade this DAOS 2.2 because it had nothing to do with technical reasons. We had to upgrade some other elements of the system, and the operations team refused to upgrade those things to support the upgrade to 2.4. So we were always running 2.2 on this system, and so I'm going to give you some results about that, which are less relevant today, but I don't know, just gives you a little bit of background of at least maybe some confidence of it running in a production-like manner. So we did a little bit of benchmarking on the system. So these are just a couple charts. So in this top dotted line is kind of like a theoretical peak for this. So in this study, our compute nodes have 8 NICs. And so here, I'm only using 4 of the 8 NICs. So the way DAOS selects a process is a bit of a round robin. So if you have 4 processes on the first socket, they'll use the first 4 NICs. So in every case, I'm always adding 4 processes, so I'm adding an equal number of processes to each NIC. And you can see the blue and red dashed lines, those are with using kind of the no data protection, the SX modes. And then the solid lines are using some kind of redundancy. So in this case, they were 16 plus 2. And you can see there's general scaling with the number of processes, and the more processes you add, especially for the no redundancy case, that they go up quite a bit. And so one of the things that Argonne will be interested in is usually the use case for users so we have 6 GPUs per node. Each GPU has 2 tiles, so a lot of people will run some kind of multiple of 12, so 12 or 24 processes a node might be a common use case for users. So that's kind of the target range that we'll look at studying the performance of, and less at the extreme ends. And so then this is just showing the overall scaling of running on our system. So again, if we take like 90% of the line rate, you get about 900 gigabytes a second as for the storage system. And you can see for the no redundant case, we're getting up close to the peak. And then as well as for read on the redundant case, we're also doing quite well. In 2.2, there was something lacking, which was rotating which nodes were using the parity. So you don't get correct scaling with the writing. But that's corrected in 2.4, and you'll see that on Wednesday. So there's a bit of benchmarking, and then so here's kind of like just a summary of what we did with Sunspot. So like I said, we were stuck with 2.2 because we couldn't upgrade our base OS to the next version, and that was just for non-technical reasons. Then our performance, for me, they were within expectations, so I was happy. Obviously the redundant performance wasn't quite as good, but there is fixes in 2.4, and so that's addressed today. And then what we were doing for testing wise, probably most users started with the POSIX defuse module, and then they would also, if they had MPIO test code, whether that was some IO library that used MPIO or they had directly MPIO code, they would move to testing that. And generally we had some success, but we also had some failures. And so then the bottom 3 bullets here, I'll talk about some issues that we ran into and we've been working with Intel over the past year on. So one of the things is we originally started like, please use some kind of error correction when you create your container. So we had given them scripts to help them create containers with the correct setting. And so all of that works, as you saw in my benchmarking slides, like you can read and write, no problem. However, we noticed when we would take a server down, which would cause a rebuild to start, that the server might go into an infinite loop on rebuild, and that had to do with something with the presence of the error correcting codes. And that was fixed a long time ago, but again, we couldn't get those fixes on the system. So that was one thing we ran into 2.2. Another thing we saw was, and I'd be curious to hear if anyone else has seen this, is systems reporting like enomem errors from internal operations. And so we would see this over time, and we were never clear where the source is, because again, there's users running on the system, we don't know what they're doing. We just all of a sudden might start seeing errors in the system or get a report from errors. A user might report errors. So we don't know where or how the genesis of this error, but that's one of our things to look at for 2.4 is, do we see this? And at least so far, on all the testing that the DAOS team has seen that are done over the past year, they haven't seen this error. So we're likely it's gone, but that's one thing we'll be looking at. And so then the last bullet is, I think, one of like our most interesting takeaways is we decided we needed like a dedicated management node. And when I say dedicated management node, it doesn't have to be a physical node. It could be like a virtual machine or something. But in our case, for like security wise, we have like a central administrative node that's, it can administer all nodes in the system. And so our operations team wants that to be the most secure node that you can have, which means they don't want us to install our management tools on that node. Because they're like, well, those are only needed for DAOS, like we don't need them for anything else, so they don't want those installed there. Second thing, I would like to use some of the management commands, but I'm in the performance side, not on the operations team, so I don't have root access, so they don't want to give me access to these other nodes. So today, we usually just use one of the DAOS servers as our management endpoint, but in the future, what we're going to do is set up a node where we have all our management tools, we have all the Unix groups set for DAOS admin, so if you're in that Unix group, you can run all these tools, and we think this will simplify like the management. So definitely a recommendation is, if you stand up a cluster and you want to do management, especially if you have a shared management infrastructure with other things, to get yourself a node or a VM that you can set up to configure DAOS, and then you potentially have a wider pool of DAOS admins, depending on how you structure your administrative responsibilities. And then finally, my last slide. So we've submitted new results for IO 500, so you'll see those on Wednesday. We submitted to each of the list. So this is our first time submitting a production submission. So we use a configuration where we can tolerate one failure. So we have a 16+1 configuration. And still today, of course, we have HPL runs going on. All the science users want to get SE results. Again, we cannot rate high enough to get all the resources. So we were limited to running on 300 clients, because that's all my management would assign to us for running test cases. And we use 642 servers. So whatever results we have, we should still be able to do better, hopefully maybe at ISC or in the future when we can do our next run. But I think you'll be pleasantly surprised, so I invite everyone to take a look at the results or join the BOF if you're here today. Any questions? All right, thank you.